Alright, hello and welcome guys to the final video where we cover the last 3 questions that have been requested. So, of these 3, one of them is really interesting. The other 2 are pretty basic. Let's get in with the first basic one right now. So hopefully you've already had a chance to, go through this exam. You already know this question. If not, pause the video, read through the question nice and carefully, and unpause the video once you're ready. Okay, so in this situation, we're trying to find the probability that exactly 6 of the computers have been infected, and they're the first 6 computers that technician checks. So the way we do this, we use this principle. Again, this has been covered, during our lockdown period, so I'm not entirely sure exactly how competent or not competent you are in this particular topic. But to take you right back to the basics, you're flipping a coin twice. What's the probability you get tails on both flips? The first coin flip, the probabilities are half, right? Half a chance you get a tail. Next coin flips, it's another half. The probability you get 2 tails ends up being 1 1/4, right? You're just multiplying the individual probabilities. We're using that concept here. But there's 20 computers, right? So what's the probability so we want to find the probability of the scenario where the first 6 computers all have the virus and then the next 14 don't, right? It's exactly 6 of the computers have been infected and they are the first 6 that he checks. We know this is extremely unlikely, right? You got 20 computers, 6 of them have infections. You're going around and checking them. What are the odds that the exact first 6 you check are the ones that have it? We know it's unlikely. Let's find out the exact probability. Okay, so what's the probability the first one comes out to have the virus? So the technician goes up, randomly picks a computer, checks it. We're after the scenario where the first 6 do. So there's a 1 in 5 chance that the first one has a virus. What's the probability that the second one has a virus? It's a 1 in 5 chance. The third one, the fourth one, the fifth one, the 6th one, right? It's extremely unlikely. You only have a 1 in 5 chance of correctly guessing. You've only got 1 in 5 chance of a computer having a virus. And the first 6 you go to having the virus is very unlikely. Anyway, let's then move on. So that's the first 6 computers. From this point onwards, he's checking another 20. And we're after the scenario where each one of these final 14 computers don't have the virus. So the likelihood that it doesn't have a virus is 4 over 5 times 4 over 5 times 4 over 5 for the remainder of the 14. In other words, it is this. That there is the probability. You've got a 1 in 5 chance of a computer having a virus. And we're finding the probability that the first 6 the technician checks all have viruses. And that is it. For the next 14 that he checks doesn't. This here ends up giving you the probability. So hopefully that makes sense. All right, the next question is a super interesting one. When I say interesting, well, I don't know, maybe it's not that interesting, but the mathematics in it is pretty fun. I guess maybe that's what I'm trying to say. All right, here we have this random inverse sine function, right? Remember inverse sine, but normally there's been some shifting that's happened here and that sort of stuff. All right, we've been given this point P, which has coordinates 3 and 2 pi, right? So we know this point lies on the curve. And we also have another point here. It's not directly stated, but clearly 2, 0 is also a point. So we have 2 pieces of information. We have 2 unknowns in the question, A and B, that we're trying to find. Right, so 2 pieces of information, 2 unknowns that we need to try and find. This should be possible. All right, so let's move on with it. I'm gonna, let's look at the situation let's look at this point down here. when x is equal to 2, we know that y will be equal to 0, right? This is a point on the curve. So we know this scenario. Subbing these values into our equation, let me get rid of this stuff here. Right, here's our equation right here. So subbing these values into the equation gives us a plus 2 inverse sine, was it x, so 4 minus b will be equal to 0. This here is our first equation. And now looking at the second point that we were given, when x is 3, y ends up being 2 pi. So subbing these, like that coordinate, or those values into our equation, gives us this result, a plus inverse sine, in this case 6 minus b, will be equal to 2 pi. This here is our second equation. Check it out. There is 2 equations, 2 unknowns. Let's solve simultaneously. So what am I going to do? I'm going to, here I can see these a's will eliminate quite nicely. Equation 2 minus equation 1. Technically I'm using elimination method here. Of course, you could have easily used substitution method, rearranged one of them to get a is equal to, and then sub that into the other. Ultimately, you're going to get the exact same thing I get here. I just think this gives it to me a little bit quicker. Equation 2, take away equation 1. I'm going to minus these two. A, take away a is gone. And then over here we end up with, I'm going to take that 2 out the front. 2 inverse sine 6 minus b. Take away inverse sine 4 minus b is going to be equal to 2 pi, take away 0. So 2 pi. Okay, so by minusing the two equations, or whether you use substitution method, you'll end up with some sort of an equation, cancel those 2's on both sides, where we've eliminated the a. Now we have one equation, one unknown, which is b. We solve this equation, we get our value of b, then sub it back into either of our equations to get a, right? That's our process. So let's solve this equation. What do we have? Okay, new page. Inverse sine, was it 6 minus b? Take away inverse sine 4 minus b, which is equal to pi. Right, so that's where we're at. From a, just remember inverse sine, right? This here, inverse sine is an angle. This over here is another angle. When you take away two angles, ultimately what you're doing is finding the angle in between. In this case, what's interesting, we take away these two angles, we end up getting pi, or in other words, pi radians, or in other words, 180 degrees. The difference between these two angles is actually 180 degrees. In other words, you know, these angles would belong on like a ray that is parallel, but a little bit irrelevant to the question, but interesting to note anyway, and a concept that might be needed, you know, for some other hypothetical question that happens down the future. All right, so we're trying to solve this equation to find the value of b. I guess ultimately, you know, the way to get rid of an inverse sine is to sine it. So I might set myself up to do that. I just can't like automatically sine both sides straight away. I actually can. And that's actually really cool. I'm trying to think which would be quicker now. Sorry, look, I'll be honest, I already previously did this question a different way. I'm just working out whether... So if I just signed both sides, and then I would have ultimately sine of a minus, or I won't use a, theta minus phi, right? Where, look, I'll just do it the way I was doing it. The way I ended up doing it previously, which isn't actually as cool, that's what I just thought of, ultimately it gives you the same thing, is I just took this other inverse sine to the other side. Yeah, it makes it, I can just sign it straight away. Anyway, it doesn't matter. All right, now that I've done that for some irrelevant reason, I'm now going to sine both sides. So I'm going to take the sine of this and the sine of this, right? You know, with equation solving, whatever you do to one side, make sure you do the other. Now, sine of an inverse sine, they're inverse operations, they undo each other. We've actually seen this concept happen quite a bit so far in this exam. Inverse operations colliding, cancelling each other out. And over on this other side, notice we've got sine of like, I know I should be doing this in orange, it'll make more sense. Here we go. Right, and we've got this situation over here on the right hand side. We've got sine of some angle plus another angle, and we know the result. Right, we're going to be using this. We're just going to be using that standard sum and difference, or in this case, the sum of result. So we end up with sine pi cos inverse sine 4 minus b plus cos pi sine 4 minus b. Now, looks kind of, oh, sorry, sine of, sine of inverse sine 4 minus b. Okay, so here we go. Let's simplify this right-hand side. First thing I'm going to note, sine pi, right? That's the same as sine 180, which is 0. That whole first term is just equal to 0. It's gone, leaving us with, in this case, cos pi, right, which is minus 1. So you end up with a minus 1 times. Here you got sine of inverse sine, them cancelling, leaving us with this. Everything's cancelled so nicely. Ultimately, all you need to do is sine both sides. That's the trick. You could have done it right up at the start. Right here, sine both sides, or you could do this completely unnecessary simplifying and then sine both sides. Use your sum result for sine, simplify it down, and you end up with, here it is, nice easy equation. Let's go ahead and solve it. 6 minus b is equal to minus 4 plus b. B's together, numbers together, we get the value of b. B is equal to the value 5. Going back to, I guess, equation 1. We know what b is equal to. So we're going to sub that into equation 1. I could sub it into equation 2. It's just as easy, to be honest. But it doesn't matter. I'll sub it into 1 because that's what I've said. And from that, I'll get the value of a. So b is equal to the value 5. Equation 1 was a plus 2 inverse sine, what's that? Sorry, it's 4 minus b is equal to 0. And from here, so we're going to let b equal 5 because that's exactly what it was. From here, then we have inverse sine of -1, you know, and again, I would say to you, if you know what your inverse sine looks like, this ends up being a minus pi on 2. So we end up with 2 times minus pi on 2. And again, if you're not sure about this, you need to go back to the graph. When the textbook, when we first learn about inverse sine, the graph and that sort of stuff, to find your exact values. And so, hey, here you have it. Okay, hence, or thus, a is equal to pi and b is equal to 5. So, certainly not an easy question, but ultimately it was a case of, well, yeah, sub in the 2 points that you were given, gives you 2 equations, and then ultimately you're just solving simultaneously. What made it a little bit challenging was when solving simultaneously, you ended up with an equation which was an inverse trig equation, right? So, yeah. Anyway, a little bit interesting. And on to our final question, question 23. So a box contains 2 red, 3 blue, 9 green, and 9 yellow balls. What is the minimum number of balls that must be drawn to be certain there'll be 4 balls of the same color? So we're talking about, even if you're the most unluckiest person in the world, how many balls do you need to pull out of this box to be guaranteed, to be certain of 4 balls of the same color? So what we'll do is, we'll assume you are the most unlucky person in the world. Let's say you get your 2 red. You get 3 blue. You pull out 3 green, right? You keep pulling out balls. You don't get 4 green, you only get 3 green. And then you move on and you start pulling out yellow balls. Again, you get 3 yellow. If you're the most unluckiest person in the world, let's check it out. What have we got so far? So 3, 6, 9, we got 11. There's 11 here. It is, although unlikely, it is theoretically possible to end up with 11 balls in your hand without having 4 balls of the same color. I would contest, is it possible to have 12? And I'm going to say this is the absolute worst case scenario. You've got 11 balls. You still don't have 4 balls of the same color. The moment you pull out a 12th ball, it doesn't matter about your luck. The next ball that's coming out, the 12th one, will give you 4 balls of the same color. It's either going to be a green or a yellow. So in this case, what's the minimum number of balls that must be drawn to be certain? Like, there's no way possible for you not to have 4 balls. It is 12 balls in total. Because as we can see here, it is theoretically possible to withdraw 11 balls from the box and still not have 4 of the same color. It's not likely, but it can happen. They're asking us, you know, we want to be certain we've got 4 balls of the same color. I say to you, take out 4 balls. You're guaranteed to have 4 balls of the same color. All right, that's it for question 23. That was actually worth 2 marks. I'm really not sure what sort of working out can be associated with it, but it's a pretty easy question, or hopefully you guys think so. Anyway, I'll leave it there. If you do have any other questions, either if you need me to go back over any questions I've covered in these videos, or you've got any other questions from your practice exams, please let me know. I'll help you the best I can, and I'll see you next time.